Hey, welcome to 10.2, where we're going to be discussing conversions between moles and mass and moles and volumes. The first thing we want to do is we want to go back over and review what we've talked about already concerning doing conversions. And the first one that we showed you how to convert between, and we're going to be drawing this in this box, we're going to draw what's called the molar roadmap. The first thing that we showed you how to convert between was between moles and particles. Okay. Now, particles can be anything like atoms or molecules or ions, or we can just call them particles. They can be formula units. Anything that's at the atomic or molecular level would be considered a particle. Some people call them a representative particle. Either way is fine. Now, to go back and forth between these two quantities, you're going to use the relationship 1 mole equals 6.022 times 10 to the 23rd. Now again, whatever you put on top and whatever you put on the bottom in the fraction depends on what unit you're trying to cancel out, of course. Alright, now, what we showed you in the last podcast, or at least at the end of 10.1, I'm going to switch up colors here, let's go with a red for this one, is how to convert between moles and grams, or mass. Okay, so put that in grams. I'll trace over this as well so that we know that it's both. Now, to go back and forth between those two, you have to use the molar mass, which comes off the periodic table. Alright, and we showed you how to calculate those. And depending on which way you're going, that will determine whether or not you put the 1 mole on top and the grams on the bottom, or if you put the grams on top and the moles on the bottom. And we'll show you how to do that as well. Alright, so let's go ahead and scroll down and let's try using the first part of this molar roadmap. So we're going to be converting from grams to moles and moles to particles. Alright, scrolling down here. Let's change up colors. We'll go with a black color here. Alright, how many moles of, let's say, we'll keep it simple. How many moles of neon are in, let's say 50.0 grams of neon? Alright, so we want to go from grams to moles, so we're starting with 50 grams, 50.0 grams of neon, and we want to get to moles of neon. So how do we go from grams to moles? Well, if you scroll up, take a look at your molar mass, or I'm sorry, your molar roadmap. We are in grams, mass, and we want to get to moles. So we're going to have to use the molar mass off the periodic table. So if you take a look at the periodic table, could be in front of you, could be at the board. The molar mass of neon is 20.18 grams per mole. Scrolling back down here. I'm going to write this off to the side. Again, 1 mole of neon has a mass of 20.18 grams. So, and we could have done that in red since we have that in red on our molar roadmap there. So again, this is what we're talking about. So do I want to put the moles on top or do I want to put the grams on top? Well, if you look, you're already in grams, so in order to get grams to cancel out, you have to put the grams on the bottom. So we're going to put the 20.18 grams of neon on the bottom. We'll put the 1 mole of neon on top. That will get the grams to cancel out, top and bottom. And when you perform that calculation, it's going to be 50 times 1 divided by 20.18. And when you perform that calculation, I'm getting 2.48 moles of neon. So this would be the answer, 2.48 moles of neon. Now to follow that up, we could say how many particles are in 2.48 moles of neon. Well, in order to perform that calculation, Again, write down what you're starting with, 2.48. Now I'm kind of going to write this up towards the top of my blank here because I'm going to use the bottom part of the blank for something else. So I have my 2.48 moles of neon, and I want to get to particles, which in this case is going to be atoms of neon. And so using my molar roadmap, if I scroll up here, to go from moles, which is where I am right now, to particles, I have to use Avogadro's number. 1 mole equals 6.022 times 10 to the 23rd. So going with my blue color here, of course you don't have to change colors, we're going to multiply this by that factor. Now again, what goes on top, what goes on the bottom? Well, if I have moles already, I need to get the moles on the bottom. So 1 mole of neon will go on the bottom. Avogadro's number, 6.022 times 10 to the 23rd atoms of neon, goes on top. And when you perform that calculation, you're going to take 2.48 times 6.022 times 10 to the 23rd. Looks like we're getting 1.49. I'm going to write it down here. 1.49 times 10 to the 24th atoms of neon. Go ahead and scratch that out. So there you go. We've gone from grams to moles in one step, and then we went from moles to atoms in another step. But we can actually do this all in one problem. Let me show you how to do that. All right. And in fact, instead of doing it down below, we've used up a little bit of that space. I'm going to scroll up. I'm going to do it just above this problem. We're going to start with our 50.0 grams of neon again. And let me show you how you can actually take care of this all in one step. We're going to first, looking at our molar roadmap, we are starting in grams, okay, right here. We need to bring that up to moles first and then down to particles second. So the first thing we want to do, once again, is multiply by 1 mole of neon over the 20.18 grams of neon to get the grams of neon to divide out. Now the only unit that we're in is moles of neon. But instead of doing the calculation right there, we can go a second step before we do the calculation. Since we know that we're already in moles, we can multiply that by 1 mole of neon on the bottom with Avogadro's number on top. All right? And so now, obviously the moles of neon divide out top and bottom. Now, for the calculation, you're going to take 50 times 1 divided by 20.18 times 6.022 times 10 to the 23rd divided by 1, and we're going to get the exact same answer, 1.49 times 10 to the 24th atoms of neon. So you can do this conversion in 2 separate steps, doing your multiplication in the middle and then again at the end, or you can use one set of factor bars or one set of fractions to do the entire calculation. Whatever you prefer is fine by me. You just want to make sure that you do your math correctly. Okay? In the next podcast, we're going to show you how to go back the opposite way. We'll start in particles, move through moles, and then end up in grams. We'll see you next time.